This is video number 5 for section 6.7 and 7.1, working with vertex form. So let's try to apply what we just learned by looking at a couple of examples. I've given you a quadratic function here. It's in that vertex form. Let's answer some questions about it as well as draw a graph by hand. Obviously, the name of the graph is just a parabola. Every quadratic function makes a parabola. Direction. Does this thing open up or does it open down? Well, we learned that all you have to do is look at the a, the number in the front, and specifically what you have to do is look at the sign of that number. Since it's a negative, I know that this particular parabola opens down. Okay, shape. Is this kind of wide or kind of narrow? Well, again, the a value tells me that. Not so much the negative or positive, just the value part of the a. The value part of the a is the 2. Since 2 is bigger than 1, I know that this one is going to be somewhat narrow. How about the vertex? Well, the vertex was simply the ordered pair made up of the h and the k. And this is where you got to be careful. When you take a look at this equation here, it might be tempting to say, oh, the vertex is 3, comma 1. That's close, but not quite right. Let me jot down vertex form so we can compare. Remember, the vertex form has that built-in minus in the parentheses. Not on the outside, it's a plus, but on the inside you have this minus. Well, when I compare this to the equation that I was given, there's no way that the h could be a 3, because if somebody had erased this h and put a 3, it would say x minus 3. The question is, where did this plus in here come from? Well, the only way that could possibly happen is if somebody came over to this and put in a negative number in place of the h so that this negative and this negative plussed out. What that tells me then is the h, in fact, is a negative 3. The k, just like it looks, is definitely a positive 1. What you have to remember is, because of that built-in minus sign issue, the h is essentially always the opposite of what you're looking at in here. The k is what you're looking at here at the end. Okay, we have the basic information. Let's talk about how we would draw this parabola by hand. And if I ask you to do that on a quiz or a test, here's the kind of work that I need to see. You're going to make a table. In the middle of the table, you should put the vertex. It belongs in the middle because the vertex is essentially the middle point of the graph. Let's go ahead and plot that. So negative 3, comma 1 is right here. And then, you can be as accurate as you want to be. We're going to decide for our purposes that as long as you have a couple of other points clearly shown, that will be fine. Here's what you should do in the table. We want to find points nearby the vertex. So unless there's some reason not to do this, just go one x value back, in other words, one x value to the left, and then one x value to the right of your vertex. Plug in those x values into the equation and figure out what y goes with them. For example, if I took x equals negative 4 and I substituted that into this equation, here's what I'll have. And then I just need to work out the math. Let's see, follow order of operations. Negative 4 plus 3 is negative 1. Negative 1 times negative 1, that's what squaring means, would be positive 1. So I have negative 2 times, this came out to be positive 1. Negative 2 times 1 is negative 2, plus 1 comes out to be negative 1. So that's the value of y. Let's mark that as well. So negative 4 comma negative 1 is right here. Now here's the great piece of news here. You don't have to plug in the negative 2, because if you understand the symmetry of these parabolas, you understand that everything that happens here to the left is replicated on the right side. Since negative 2 is also one space away from the vertex, it has to be that the y value there is also -1. Now you could obviously plug that in and check it, but you don't really have to. You can use the symmetry to help you. That's enough, I think, to give yourself a reasonable picture of the parabola. Just try to connect the dots, make it look like a parabola. Obviously, if you wanted to, you could go to the graphing calculator and do a double check of this picture. But this will be sufficient, I think, for graphing them by hand. Vertex in the middle, point on either side, connect the dots. Okay, oh, by the way, there's a box down here that talks about how you'll graph such a thing in my math lab. It's pretty user-friendly. It's very similar to when you drew lines. Instead of clicking the picture of the line, you'll click the picture of the parabola, the up and down parabola. And then what they want you to do is they want you to click in the vertex. So obviously you'd click this spot in right here first. And then they just want you to click on one other point on the parabola. So maybe this guy that we did. And then the computer draws all the rest of it in for you. So it's probably easier to do it in the computer than it is by hand. Let's answer the remaining follow-up questions. We're being asked for the domain. Remember, domain is just a list of all the possible x's that could ever show up on this thing. Well, this thing just keeps getting wider and wider and wider as it goes down, so eventually it'll hit every single x on here. I mean, even an x like x equals 6, it'll take a while. It'll be way down, I'm sure, off the screen before it gets there, but it'll get there eventually. So the domain is just all real numbers. And in fact, that's the case for every single parabola that you're ever going to draw. How about the range? Well, that is not all real numbers. Range refers to all the possible y values that ever show up on this thing. And you can see, I mean, there's some y's up here that are never, ever going to touch this parabola because this vertex spot is the highest spot. Everything else goes down from there. So the range would be all the y's from the vertex value down. What is that value? It was at 1. So the range would be y's that are less than or equal to 1. Remember, the 1 here came from the k value, this one. In fact, the range will always have a connection to that k number. Last question, how many x-intercepts does this parabola have? X-intercepts just mean the places where the graph hits the x-axis, and you can tell that it happens twice. Once somewhere a little bit to the left of the vertex, so somewhere around here, and once a little bit to the right of the vertex, somewhere around here. So this guy has 2. Notice they're not asking me to say what they are. That would be too difficult to figure out from this picture. In fact, we haven't even learned the algebra necessary yet to figure it out from the equation. That'll come later on. We're just being asked how many there are. As a side note, you might think about what other possibilities there might be. This particular parabola had 2 x-intercepts. Will they all have 2 x-intercepts? Definitely not. What if the parabola was just a little bit lower? Well, then it might not have any x-intercepts, right? If it looked like this, it wouldn't even cross the x-axis, so you could have none. Or what if you had one where the vertex was right on the x-axis? Then this guy would have 1 x-intercept only. That's all you have. You can have none, you can have 1, or you can have 2 like we did here. Okay, let's try one other example a little more quickly. This is actually a simpler example, but the look of it tends to throw people off, and so I wanted to mention this one to you. One of the first things is it doesn't really even look like this guy is in vertex form. It feels like something's missing. Where's that parentheses and everything? But in fact, this is a quadratic function, and it is in vertex form. Let me show you how that is. The reason the parentheses are missing is because the h value must be a 0. If somebody fills in a 0 right here, then this whole part would basically disappear, and all you'd have left in here would be x squared, which is what I have. So if you see something like that, you might even want to write it in this other way just to help yourself see what's going on. Okay, let's start answering the questions. Obviously, once again, this is a parabola. Since the a value is a positive number, that means this particular parabola opens up. As far as the wide and narrow thing, I concentrate on the value part of the a. The value part is a fraction that's below 1, 1/3. Those were the kind that gave us a wide parabola. The vertex I can read right out of the equation. It's just the h and the k. You can see where writing it in this format here is kind of helpful while you're getting used to this idea. Clearly the h is 0 and the k is -2. Remember, the k at the end of that thing is just plus k. So somebody must have written plus -2. Plus -2 is the same thing as -2. Okay, we have the basic information. Let's go to make a graph now. We said we were going to put the vertex at the middle of our table. So there's the vertex. And then we said we would go one spot to the left, one x value lower, and then one x value higher. Normally, that would work fine. But in this particular problem, that's not going to be so great because that would be putting, don't write this, but that would be putting -1 and 1 here. The problem is if you want to take one of those numbers and then stick it up into this equation, you're going to get a messy fraction. And that's just not helpful in terms of graphing these things by hand. So when fractions are involved, sometimes you have to do a little bit more thinking about what x value to use. Let me mark the vertex on here before I forget that. I had wanted to use -1 and 1 for my x, but I really need to pick something that's going to wipe out this fraction. Let's see, what if I went 2 out? Would that do it? No, 2 here, I'd still have that 3. What if I went 3 out? Well, I think now I'm in business. 3 squared is going to be 9. 3 goes into 9, so that's what I'm going to have to do. I'm going to have to go 3 out this way. You always want to be symmetrical, so I'll go 3 the other direction to -3. Pick one of these x values and stick it in to the equation. Remember, you only have to pick one because of the symmetry that's involved. So I think I'll just pick the +3. Let's go ahead and plug +3 into this equation and then work out the math. 3 squared would be 9. I need to multiply 1/3 times 9. I'll write that 9 over 1. I've got some canceling, which is exactly what we wanted to happen so that the fractions would go away. And I believe I've just been left with 3 take away 2, which is 1. And so back in my table, I know that the y value is 1, and because of symmetry, it's got to be that the other y value is 1 as well. So 3, 1, as well as -3, 1. We were expecting kind of a wider shape this time, so this seems to fit with what we were expecting. And then just connect the dots in a nice parabola shape, and we're done. Remember, the work that I'm showing here is the work that I need you to show me when I ask you to draw me a parabola by hand. Let's answer those follow-up questions here quickly. The domain, we said every single time, is all real numbers. The range is not all real numbers. We said it'll always have something to do with the value of k. In this case, k was -2, and since this parabola opens up, the range would be all the y values from -2 and higher. So y's that are greater than or equal to -2. Again, you know it always has something to do with that k. As far as how many x-intercepts this guy has, well, I can see clearly once again it's hitting the x-axis somewhere over here, and it's hitting the x-axis somewhere over here. So once again, I have 2 x-intercepts. The only way to get good at this stuff is to do a lot of practice, so make sure you're really going through the homework carefully so that you can drill all of these ideas into your head.